airports. I'm not going anywhere right now, planning to stay at Max for a couple more days. The reason we came here is we want to chat with Fedex. Now Fedex have been customers of ours for a long, long time. I actually remember visiting Fedex back in the 90s as early Cold Fusion customers. They use Flex, they use data services, significant lifecycle deployments as well. But there's one small group within Fedex that doesn't get as much attention that is doing some very innovative work with enterprise applications. Now, as we told you yesterday, the problem with most enterprise apps is, well, they look like enterprise apps. But they don't have to be that way. And so my next guest I'd like to invite up is a strategic technologist for Fedex Custom Critical. Please welcome Adam Mollenkopf. Good to have you here. So first question, what is Fedex Custom Critical?
Custom Critical is a very unique part of FedEx where we ship things that need to be shipped as fast as possible, or things that have very special needs for special care and handling.
What kinds of things are we talking about?
Cryogenics, hazardous material, museum artwork, all kinds of sensitive and high value shipments.
So this is pretty critical stuff, hence the name. And so it's stuff that needs to be monitored very carefully, a lot of control over. Okay, so what was the business need? What was the requirements behind this application?
We need to have a very good way to track these items very closely with very low latency, which is why we looked at the lifecycle products, so we can basically see these in a tracking and monitoring application.
Cool. Can we see this application?
Absolutely. Okay, so what you're seeing here is an application where our control center agents and our planners will basically view capacity balances in our fleet. So this will basically be where our vehicles are, where our shipments are. And as we drill down into these clusters expand into more detailed views. And we can look at this and see that we've got extra vehicles in this area, and we've got less vehicles in the Chattanooga area. So we may look at this and reposition vehicles accordingly. So pan over here to the Dallas market and look at the activity in this area. We can see that we've got vehicles, these purple triangles. This is a real-time continuous feed of what's going on.
So this would require that you actually have monitoring and sensoring equipment on the trucks themselves.
Correct. So we've got GPS positioning on these vehicles. It's real-time. If I drill down into one of these specific vehicles here, we're going to go view this in a tracking view. And what we're going to see is I'm going to replay this. This is a historical replay of one of our shipments that we had in the past. And over here, we're going to zoom into the Dallas market. We can see that we've got this funny looking red shape around here. And what this is a travel time proximity fence that tells us when the vehicle's within a certain number of minutes into that location. So for this specific customer, they've registered to be notified whenever we're 15 minutes away from their dock facility. And what we see here is we're starting to get alerts that says the pickup has been auto-notified. So the agent didn't have to call the customer, the driver didn't have to call us to tell him that we're 15 minutes away. And now we've got other fences associated with this as well. This little green area is a 1-minute travel proximity, so it doesn't matter how the vehicle approaches this. They can approach it in any direction. But as soon as we cross that bound, we associate that to an automatic arrival at that pickup location. So again, the driver didn't have to send us a message and tell us that they arrived. We automatically infer that from there. If we go into the vehicle view here, this specific shipment is a pharmaceutical shipment that's got high-value goods on the back. And basically, they're perishable goods. We need to maintain the temperature range for the course of this shipment. And we're needing to maintain a range of 2 to 8 degrees Celsius. These are real-time probes that are deployed in the trailer of this vehicle. So you'll notice that the data is changing. And something bad just happened here. This red button here, the green button turned red here, and the temperature control unit has just turned off. So this may be an indication that we need to track this a bit closer. This is a historic trail of the temperature reads that we've gotten from this vehicle in the past. And what we're seeing now is our trends are increasing here. So there's a reasoning engine behind this that's basically looking at sliding time windows of interest and keeping moving averages of these temperatures. And it's telling us that we're increasing our temperature. And basically, if we get to the 8-degree range here, we're going to be at trouble and we're going to have a risk for a liability claim on the commodity that's in the back of the truck. So this is powered by the RTMP. This is the same service as powering the video there. So the data is going over this RTMP channel to this client. Now, our reasoning system just told us that a 1.5 degree rise has happened in the last 30 minutes, so somebody's definitely involved with this shipment at this point if they weren't already watching this. So they're going to get involved with the driver and figure out what's going on here. In this case, the driver sent us a message back that said his fuse is blown in the refrigeration unit. He had a spare, but it failed, so he needs immediate repair. So now the control center agent is going to find the nearest repair facilities to this location that could potentially satisfy replacing the broken part on this vehicle. So we're going to see that we're going to reroute to the north part of Birmingham here and add 22 minutes to the route. So you'll notice that the original planned route for this shipment, which they're being guided on through an in-vehicle navigation system, is now rerouting them to this location, and our reasoning system is now telling us that they've entered a different path on this route and it's going to delay them 22 minutes. But we're expecting that because they're being rerouted to this location. Now, the data that we're bringing in here is real time. We can blend in satellite imagery and other kinds of data as well, if that's important. And basically, now we're detecting that there's a decrease in the speed on this vehicle. Since it's not going on its normal part of the route, we're showing a decrease in speed, which is telling us that we may have a security situation. So again, there's high-value goods, maybe multi-million dollars of goods on the back of this truck, where we need to basically monitor that from a security perspective. Now we're going to look at the delivery location, and we've conveniently got fences around that location as well, so we can notify the customer when we get close to their location. And if I look at the ETA timeline on this, you'll notice that the truck is progressing towards the destination here. And now it's getting very close to the destination. We can see what the performance of this vehicle was historically here, and we can notice that we added 22 minutes in the middle of the route here. So this was when we fixed the issue with the temperature control unit. Now, it's okay that we added this 22 minutes to the route because we actually promised the customer a time that was at 3:36, or we actually delivered at 3:36 and we promised the customer 3:58. So we still met the customer promise time, and we're able to proactively, via lifecycle data services, notice abnormal events and intervene to fix those before we had a risk for a liability claim.
Pretty incredible. What do you think? I agree. This is what enterprise applications should look like. They should be useful, they should be engaging, they should provide visual feedback. I do have one question though. You didn't put the sensors in the trucks for this app. You actually had made prior attempts to build this that didn't work as well.
Correct. Yes, we tried this through a number of other platforms, Ajax in specific, and had issues with that in the past just through performance and scalability. And via the RT and P channels that are available on lifecycle data services, the volume that we're actually pushing over that's pretty laughable compared to the volume that's being passed over on the video streaming.
Cool. Couldn't have said it better myself. So lifecycle data services, Flex, allowing you to build a very compelling, very engaging enterprise application. Thank you for sharing this with us.
Thank you.
Thank you. That's a pretty impressive enterprise application. And as you heard yesterday from Rob, we are committed to taking everything we know about building more engaging, more compelling applications and applying those to the enterprise. Enterprise does need this kind of experience as well. Now, yesterday we were also talking about how applications are built. We talked about Code Fusion Builder and